Since it's the last session of the day, I'm going to start now so we can leave early and get ready for the happy hour. Yeah. All right. Welcome back. If you were in our previous session, if you're new to our session today, my name is Ron Dagdag. I'm a Director of Software Engineering and also a Microsoft MVP. Today, I will be talking about making neural network run in the browser with ONNX. All right, let's get started. Okay, let's see if it works. Anyone familiar with neural networks? I've played with neural networks before. Oh, we got a few people. That's awesome. Machine learning. Yeah, all right. Python developers. Of course, if you played with machine learning, most likely you've done some Python. C# developers. Oh, we got a good combination. Web developers. Oh, wow, it's the same hands. That's awesome. And JavaScript developers. All right. We're in the right crowd. That's awesome. Thank you. Pokemon fans? All right. Pokemon, I say that because I'm going to be talking about ONNX, not ONNX, right? ONNX, not the Pokemon ONNX. I'm going to talk about ONNX, just to get the difference. All right, I did talk about this, but I always like to iterate this, especially if you're new to machine learning. And so just going back to the basics, especially when you're doing software development, there's three things that you need, right? Input, algorithm, and it'll give you the answers. In this case, like our boss tells us, hey, you need to build a calculator. You need the algorithm for addition, subtraction, all these calculations. And then with your input, and then it will give you the answers. Oh, I'm running out of battery. In machine learning world, it flipped the other way around, right? It's input, then you have to give a bunch of answers, a bunch of examples. And the goal is to create a machine learning, the goal is to train the computer to create an algorithm for you, to build an algorithm. So as a machine learning primer, the right side is your programming, left side is machine learning. You have your input, answers, and then algorithm. In machine learning world, we call that training data. You need lots of training data, and you pass into the training framework in order to build a model for you. And that model, you would use that integrate that with your application. And then in machine learning world, that's what we call inferencing. And you need inferencing runtime, then you'll give you the answers. And then, of course, it's a feedback loop, right? As you improve your system, you need more training data based from the usage of your app or from other things, and then build a better model. We did talk a little bit on the previous session about ONNX. I'm gonna, so some of you may be familiar with this. A lot of data scientists, if you're starting with machine learning, a lot of examples out there. It's either TensorFlow, PyTorch, a lot of Python world, right? And typically you'll run it locally in your machine, CPU. But in real world, if you're a JavaScript developer, there's a lot of JavaScript framework. Machine learning world, there's also a lot of JavaScript, or a lot of machine learning frameworks that is available out there that you can use. And of course, when we deploy our apps, there's always, not just running it on a desktop, there's also the need to run through an IoT device or run it on a phone or the cloud. And of course, you have different operating systems and also different GPU, FPGA, different ways in how you would run this. And there's new chipsets that are coming out that have neural capabilities or computer vision already integrated as part of dedicated CPU or dedicated processing unit just for for machine learning. And of course, that's where it's the bridge. ONNX is the bridge between the training side and also incorporating it into your application. Think about ONNX, like I said, kind of like a PDF file. You create it in, let's say Microsoft Word, you convert it to PDF, and then now you can share that PDF and view it in like Kindle, or you view it into different places, or you can view it in laptop, tablets, or the cloud, wherever it needs to be. So ONNX is like that. So ONNX is Open Neural Network Exchange. It's an open format for machine learning models. It's not just limited to neural networks. Also, traditional machine learning spec is also available. It is on GitHub. If you go to github.com/ONNX, or the best place to learn more about ONNX is ONNX.ai. Every time I do present about ONNX, I had to update this because because there's a lot of partners out there that is contributing to this open source project. Notice how a lot of them are big names. The reason, ONNX got started between Microsoft and Facebook or Meta collaboration, and now has expanded to a lot of the different platforms. So there's also not platform independent, right? You have all these different platforms that are available there, and also different companies that are using it, incorporating it with their existing offerings. It is on, like I said, it's on GitHub. It has about 13,000 GitHub stars, 220 contributors. It's a graduate of Linux Foundation AI, and what I'm trying to get at is it's available for production. It's ready for production use. So when should you use ONNX? You would use it if you have something that is trained in Python or ML.NET, and you want to deploy it or incorporate it with your C# or Java or JavaScript application. If you're using PyTorch and you create a PyTorch Docker image, it already is about 4 gig, almost 4 gig, just to containerize it and deploy it. So, but if you need something lighter, rather than using PyTorch, you can use, these. You can also use. There's a Python for ONNX too. So it's not just limited to all this. If you have high inferencing latency, and if you need it for production use, you really need it fast, it's really optimized for production use. If you have something that's resource constraint, like an edge device, you can, or an Internet of Things device, you can start incorporating this. Like it will run on a Raspberry Pi or something that is, or that like. If you want it on a different OS, let's say a lot of people would use Windows to train, or use Linux to train their machine learning model. Now you can run it not just limited into the OS where it was trained, or different hardware, right? So if you're running it on an Intel chip, and it'll run on an ARM chip, or on the phone. You can use this also to combine running models. Let's say in a bigger team, maybe there's an expertise with PyTorch, or another team is expertise with, let's say TensorFlow or Keras, and they build their model there. You can convert it to ONNX file, and now you have one framework that you can just integrate with your application and reuse this different ONNX model rather than all these different models. And then there's also a way you can have transformer models where you can train locally rather than in the cloud. So I did talk a little bit about what is ONNX and when to use ONNX. Next step on our agenda today is how to create an ONNX model, a little bit of deep dive there, and how to deploy an ONNX model. So creating one, that is the step one, then Then step 2 is to deploy. So let me tell you a story. Back in the pandemic days, I wish I can say, it feels so different saying that, but when it first started, there's a lot of shortage and we couldn't buy bread, and my wife and I, they gave us a bread maker. We were married for 10 years, and the first time we used bread makers during the pandemic. So to make the long story short, we tried to make a bread for the first time, and we failed. We didn't know the secret of how to make bread. Even though we followed instructions, we found out that you need to use warm water rather than a regular water when you mix it with. Anyway, we messed up on the first one. What I'm trying to say here is that your data scientist, they actually build the secret recipe of your company. What they do is they experiment on all these different combinations to create the correct model and what fits with your data set. So their goal is to create these models that would, they would try, they experiment, and find out the secret combination of what would work well for the specific data set so that it can predict properly. So that's what I'm. So to talk more about what is this ONNX model, an ONNX model is just a graph of operations. So if you think about data coming in and then passing it with this function, these methods or these calculations, and then at the end it gives you the result. You can visualize it using this Netron app. It's also in GitHub, it's free. If you want to visualize what an ONNX model looks like, if you go to netron.app, upload an ONNX model there, and you'll see it looks like this. And we'll give you an example later on. So 3 ways in how you generate and create an ONNX model. One is using ONNX Model Zoo. Another one is using Azure Custom Vision service, and then of course converting an existing model. ONNX Model Zoo is on GitHub. You can download existing models out there that already been converted to ONNX for you, especially if you're talking about image class, in this case image classification. There's also other things there that you might want to experiment. These are the reference paper out there, how they trained it. These are pre-existing models that you can start using, and maybe you can start experimenting and start from there, right? Using that ONNX Model Zoo. Another way is through Custom Vision service, where if you go to customvision.al, a place where you can upload photos and label them. Like in this case, I'm uploading pictures of fruit, and then I tag them and specify these are the pictures of fruits. And then you can click train. It would run and create a model for you, and then you can export it as an ONNX model. So far, that's the simplest way, especially if you're trying out something that is custom vision. It's custom to your data set. So you have to upload specific pictures on how to classify them or do object detection. You can use it with this. Another way is converting the model. If you want to convert it, there's different converters that are available out there, pretty much in a lot of the frameworks. 3 steps in order to do that: load the existing model in memory, convert to ONNX, and then save it to an ONNX file. So PyTorch, this is the simplest example. If you're familiar with Python, you load the .pt file. In this case, it needs this input. This is in a way it's image classification or image detection. It's doing 3 by 24, 224 by 224, and then export it to model.nx. And that's about it. You can do Keras also. Just giving you examples on how you would do this. And it's pretty much the same way. There's there's ONNX ML tools that you have to install in order to do this, and then convert it to an ONNX model. You can also do it through command line. In this case, there's a command line for TensorFlow. A lot of examples out there. Scikit-learn. So I'm just giving you a little bit of examples of how you can use it. Best place to learn more about how to convert is using this URL, github.com/onnx/tutorials. All right. Can anyone, let me tell you another story. Well, not a story. I want to ask this rhetorical question: what's the difference between a baker and starting a bakery? Anyone can guess? It's still kind of late in the day. That's like.
It takes more dough.
It takes more dough. Yes. Starting a bakery takes more dough. Yes, definitely. Yeah. So baker, they specialize into you experiment at home, try the secret formula, bake your cake. But starting a bakery, it's a different skill set, right? What I'm trying to say here is us software engineers, because a lot of us are software engineers here. We know how to start a bakery. We can empower a baker to start a bakery. Does that make sense? If you think about it, we know where to put the cash register. We know how to scale. We know how to receive customers. We know how to put them together and able to incorporate with our existing app and get the business application using the models that they create. They may have created the secret recipe, but we know how to turn that secret recipe into something useful for our organization. And that's the secret there. And that's the reason why I'm excited about machine learning, right? A lot of the examples out there, and every time you see this, is a lot of is experimentation phase. They teach you about how to experiment, how to try these things. But how do you integrate it with something that is your application? And that's where the rubber meets the road. That's when it becomes useful, and that's when we see the magic, right? And so that's why my focus today is on the second part of things, right? So typically, here's an end-to-end process of how you do machine learning, where you have, like you have a Jupyter notebook. A lot of people or a lot of data scientists may use that, or maybe you're using Visual Studio Code. You train it locally on your machine, or you train it in the cloud. You create a model, and then based from that model, then we do the deployment side, where maybe you're building an image, you're putting it maybe in the Kubernetes and deploying it and monitoring that service. The critical part here is the place where you register and manage the model. So think about it, you're doing experimentation. Experiment number 1, preparation A to preparation H, right? That kind of thing. So now which one is the final version, preparation H? That's the one we're going to deploy, right? We need a place where you can register and manage these models as it gets created. So you can create the model, you can convert it to ONNX, and Azure Machine Learning has that capability to register and manage the model for you. But think about it, it's like models are algorithms, right? You need kind of like a way to have, kind of like GitHub or Git, right? History of what you deploy. Where did you deploy it? Which input is compatible to what? Right? Those are the things you have to think about whenever you're doing the deployment side, which is the step 2. So of course, different ways where you can deploy it. Maybe you can deploy it on a VM. Maybe you can deploy it on the device itself, an IoT edge device. Maybe you deploy it on an app, iOS, Android, all these different places where you can have it to. So today, so I did talk a little bit more about that. And there's always the difference between are you going to deploy it in the cloud or at the edge? So the good question there is, what's the difference between McDonald's and Subway? McDonald's, where do they bake their bread? They bake their bread in a factory or an offsite. And of course, Subway, they bake their bread at the restaurant, right? So there's a difference between the cloud and the edge. Is a lot of it is planning. There's advantages of each one, right? Is it centralized, baking the bread, or decentralized, or having it locally at the store? So those are the things you have to think about whenever you're building these infrastructure. And of course, what is the edge? Cloud, whenever you're deploying these models, you have to think about maybe you're deploying into some of the containers, different places, maybe thousands of servers. But now, if you're going to deploy it to edge devices, it might be billions of devices out there where you're deploying it, depending on your app. But different ways on how you would think about where you would deploy that model. So ONNX runtime helps us to do inferencing on ONNX model. So it's actually it's open source by Microsoft as an MIT license. It comes with Windows 10, Windows 11. It's extensible architecture. To learn more about this, onnxruntime.ai. And if you go to onnxruntime.ai, like in this case, we did talk, now we're going to the JavaScript side of things because we're going to do the inferencing side. We're going to try run it on Windows. I specify the API's JavaScript. Architecture, we're running it locally on the browser. In order to do that, we use npm install ONNX runtime node. So in order to run ONNX, there's ONNX into JavaScript, there's ONNX runtime JavaScript. You can use Node.js binding. You can also use it in the web and also React Native. So let's start on each one. Let's start with Node and how you would do this in Node. You can also incorporate this with Electron, and it does use WebAssembly in order to run it in Node. So npm install ONNX runtime node, and then of course you import it to your application. So let's give a quick demo real quick. Any questions so far from what I talked about? Feel free to stop me or if there is. Okay. All right, so let's do a quick demo on what it is in Node. So I have this Node application on my package JSON. I did npm install ONNX runtime node, and it added it. Okay. So I have this ONNX model that I generated, and I want to visualize what that ONNX model looks like, and maybe give us an example. See if it'll work. So a while ago, it wasn't visualizing. Oh, now it's better. So in this one, there's two input that it needs: years of experience and salary, and then the output would be this score.output. It's just the simplest example. Typically, you'll have a lot of input. In this case, one input, one output, and then give you an example. So, but before I do that, before I go through the Node application, I wanted to kind of showcase how I trained this and converted to ONNX, right? So just because I didn't demo that on the previous one. So how did I create this model? Okay. Here I'm using .NET Interactive and using it in Visual Studio Code. I'm using Python Notebook because you can create Python notebooks now in Visual Studio Code, and with C# backend, not just Python. So in this case, I have my NuGet packages to create this ONNX model, to train the model, Microsoft.ml, Microsoft.data analytics. So that's how I create my NuGet packages. And this one right here, some using for my data. My data looks like this. Well, simplest example, one input, one output. My input is years of experience and then salary, years of experience and salary. So what we're trying to get, based from this input, I want to guess what the output should be. so it's regression. Okay? Just the simplest example out there. So that's what the data looks like. And this one is using data ML.net. I kind of describe what that data is. Kind of gives you years of experience and salary. This one is shuffles my data set and split them into two. So I have 30 items on that list. I want to get the first 27 items, and then 3 is for my testing. I'm using Microsoft.ml to create this ML context. In this ML context, that's when I pass in my input and then use this trainer. And this trainer creates the pipeline for me based from that output. The output is salary. And once I train it, it's running locally on my machine. I train it, it will create the model. So there's always a pattern. It's always fit and then transform. Fit and then transform. So fit, it creates the model for you, this transformer. And then in order to test that, you pass it to transform, and then it'll give you the metrics. Once you have the metrics, it kind of gives you an idea how good the model was generated. And in this case, once I have the model, I will convert it into an ONNX model. So how I did that, just 3 lines of code. What is the name of my model? And I do context.model.convert to ONNX, pass in the model, the sample data, and then the stream where to save it, and it would generate me an ONNX file. So that's one way to generate it. Okay? So now, once I have my ONNX model, what I'm going to do is I'm going to use it into my JavaScript application. So I have something that's written in C#, created the model, converted to ONNX, and then now I'm integrating it to a JavaScript application. So in JavaScript, this is the simplest example based from that input. You use ONNX runtime node. There's 3 steps involved in order to do this. You create a session using that model.ONNX. You pass in the feed, or pass in the input. And in this case, how I know what to pass that in, I use Netron to know the input based from here. It requires years of experience and salary as part of my input. In this case, I don't know, salary is not being used. And if you look at this, salary is just a pass-through. I don't know why model generated that way, but that's what it needs. So that's what I need to pass. But years of experience would pass through here, would create these and do some calculation, and it will give me the output of my model. So how I know the names of what I need to pass in for my feeds, of course, this years of experience, that came from here, right? And how I know what tensor size is, in this case, it's just 1 by 1 item. So I pass in years of experience and then pass that in and created a tensor. Once you have a tensor, then I run session.run, pass in the feeds, it'll give me the results. And based from that result, I know I need to get that data from score.output, and I can display it. So if I want to run this application, hit node. It's a bit boring because based from my input 10, it gave me an output of 120. Does that make sense? This is just, it's simplest example, but one I wanted to showcase is, you have an input, execute or pass it to this model, give the output, and now it's running in JavaScript and not in Python, and not in ML.net or not in Python. Cool. Any questions so far? What if you give it 10.5? Yeah, I mean, since it's regression, you can. let's try to change the data if you want. So let's put 11.5. So it won't be close. Save it and just run. So now it's one, it's just the different result, right? Okay. So how would we run it in ONNX Runtime Web or ORT Web? This one is a JavaScript running library running ONNX model on the browser itself. It's using WebAssembly and WebGL technologies. It can both use CPU and GPU. And if you want to use this in React, there is an existing template out there that is available for you if you're using Next.js, and you can start from there. And it's a simpler example. Of course, you would install npm install ONNX Runtime Web and import it into your application. Why would we want to inference in the browser? Because it's faster. If you download the model, run it locally, you're not sending data to the cloud. You do your inferencing locally. It also works offline, so this would be very useful if you have, if you already cached the model locally, and if it doesn't have connection to the internet, it's not relying connection to the internet because it's running in the browser. It is safer, especially if you're doing video processing or image processing. You're not sending data outside of its network. It's running locally. And it's way cheaper because it's using the GPU of that machine or where it's running at. Or even if you're running on the phone, it's using that on the phone. When should you not use and run machine learning models in the browser? Well, some of these models, I would admit, it's very large. It depends on what they used for as a base to create these models. Sometimes it's large and it requires higher specs in order to run it locally. And of course, you also have to think about it. You had to download that model into that device. And if you want to secure it, then you have to kind of figure out how to do that and secure it on the browser. Because it downloads it to there. So let's do a demo. How we are on time? I think we have good. We're still good. Okay. So I have this other project, and let me run it first. Then I'll walk you through the code. I have these. I'm going to serve this website locally on my machine. There's index.html. I downloaded from ONNX Model Zoo this emotion-fur+-8.onnx. This is an existing model, and I just want to use it into my application. What does this ONNX model looks like? Let's try to visualize it. This is a neural network, and that's what typically happens. It starts with this input, and it starts processing all the way down until it does its prediction, and this is the output. So there's two things that this model needs, right? Input has to be input 3, float 32 1 by 1 by 64 by 64. So what it means is 64 by 64 pixels and one, it's black and white or grayscale image. And then output would be a float 32 of 1 by 8. And reading a little bit more about this is this model, the 1 by 8 means it's detecting, this model is detecting if it's happiness, sad, or emotions, right? It's part of the sample. Okay, let's try it since it's running now. I will localhost. So this is not a best website. But what I wanted to showcase here is I have a picture right here. I'm going to pass that picture. And remember, that model requires us to be 64 by 64 by grayscale. And so I had to convert it to that and then run it through the model, and it'll give me happiness. Of course, we're happy. It's almost happy hour. We're ready for that. Okay. So let's walk through the code and what that looks like. So index.html, of course, that's just the website, but the main thing that happens here is this. I have this main.js, and of course we have these ONNX runtime web, ort.min.json, or not JSON, ort.min.js, that we're incorporating it into our application. So it's going to run in the browser. And then what is this main.js? What does it do? In this case, once I get the file, right, I receive that file, I'm going to load that image. And once I load that image, I will handle that image. Once I handle that image, I have to resize it to a certain, to that correct and do some pre-processing, because the model requires me to resize whatever image that I passed in. And once I resize it, I have to convert it to tensor, and that's what I'm using here. Processing image, I'm just using the canvas to resize it and specify the width. To convert it to tensor, I'm using this float32 array, passing it whatever it needs from that, from the, what is this, max length? So it's dimension 0, 1, 2, 3. Oh, anyway, the input size, right? It's 1 by 1 by 64 by 64. That would be my max length, because that's what my model needs. And then go through each one of those, convert it into this float32 data, convert it to this ort.tensor. I pass that in, and then based from that, once I converted it into a tensor, I loaded the ONNX model. Remember, 3 steps. Load the model, create the session. That's the first step, right? Based from that model. Based from that, I had to create the feed, pass in this case, input 3, because that's what is the requirement for that model. I pass it to the session.run, it'll give me the result. And then how I know whatever this output is, it tells me on these ONNX, this Netron plus 692 output. And that's what I would use. And then I figure out what is it's either neutral, happiness, surprise, sadness, anger, based from that output, whichever is the maximum from that array output is what it's going to display to. And that's pretty much it. But you see the pattern, right? You create it somewhere else, you integrate it with your application. 3 steps involved in order to integrate it with your application is create the session, pass it to session.run, and then process the output. Cool. So what just happened? We created, we hosted we have a website that would process a model, right? Have an image, resize it, pre-process it, do the conversion, and then get the results. If these are some of the resources. If you want to experiment on this, there is this demo that talks a little bit more if you want to use, like in this case, MNIST, right? So if you want to try this out, number 4, it tries to guess as you clear as part of your canvas. So that's not 8. Of course, it's not perfect, right? It's thinking it as 6. So based from that data. So it depends on how it's trained, but that's what it looks like. Okay. React Native, I don't have time to demo this, but React Native, you can use it also. The difference is it allows you to do it in Android and iOS, but you have to convert it from ONNX to something that is optimized for mobile. It's called ORT format model, and then now you can start integrating into that application, into your React Native. So as for compatibility chart, if you're doing it on Windows 10, it runs on Chrome, Edge, Electron, or Node.js, using WebAssembly or either WebGL. It works with Mac. It will also work with Ubuntu, iOS, and Android. So that's very, now you can cross, it's cross-platform compatibility. And this is how it feels like after showing you all these, right? Yeah, I know it's late in the day, but once you understand that, what is ONNX for? It's an open standard, so you can use the right tool for the right job, right? That you are confident that the model would run efficiently on that target platform. So if your developers are, if your platform is JavaScript and you want to run ONNX on it, you can use ONNX runtime. How do you create ONNX model? You can be created using ONNX framework. I did show you a demo on how you would do it in ML.NET. And then how do you deploy an ONNX model? You can deploy it using Windows ML. You can use it in your JavaScript, Python. You can also use it in the cloud using Azure ML and with the use of ONNX runtime. If there's anything else that I want you to remember, I want you to picture this every time you're working on a project, a machine learning project. And when you use the model, separating out what you use for training framework and using for inferencing runtime. If you're interested in getting some of the samples I did demo today, feel free to go to that link and capture this and try it out. Oh, by the way, if you want to experiment on, this is actually a Snapchat AR glasses. In order to run machine learning on this device right here, you use ONNX to do that. And I think that tells you the different capabilities of this ONNX platform to try it out on different devices. So if you want to learn more about me, my name is Ron Dagdag. I'm a director of software engineer at Spacey. I got just recently re-awarded as a Microsoft MVP. The best way to contact me is through LinkedIn or Twitter at Ron Dagdag. And I appreciate you geeking out with me about ONNX, about making bread, and all the things bread. Thank you for your time. I know this is a different, it's kind of hard topic to understand, but it's hopefully you got something from it, and thank you.